So what are we going to say? Your hydrogen now it's 4 times 3, which is 12. All right. So this side I've got 2. So for me to balance, I need to put a 6 here, so that they are 12. So my ratio is going to be the P4 is 1, the hydrogen they are 6, and the phosphorus trihydride they are 4. So my answer must be 1:6:4. That would be the answer. So I go and check on my choices that have been given. We're looking for 164. All right. So the answer comes out as B. So your option there is B, 164. That becomes your answer. That's the balanced equation. Right, so that's how you balance that. So those were the 3 multiple choice questions that I gave you. Right, we move on to the next question, which is your long questions here. We are given, learners investigate how the type of substance affects the electrical conductivity of a substance. They conduct 3 experiments using 3 different substances under the same conditions as shown in the table below. So you're given experiment 1, 2, and 3. You've got mass of substance, you've got the mass of substance for each experiment was the same, 2 grams, 2 grams. Then the type of substance, for the first one there, you've got your calcium chloride, the temperature 25. The next one, solution of potassium chloride, you've got also temperature 25 degrees Celsius. You've got a solution of sugar, 25 degrees Celsius. Then the first question says, define the term electrolyte for 2 marks. All right, what is an electrolyte? Right, it is a solution that conducts electricity through the movement of ions. So this one you can either add it or you can leave it. So it's a solution that conducts electricity. It can be a solution, it can be a gel-like solution. So it does not necessarily have to be watery. It can also be gel. All right, I think some of the batteries, most of the batteries, they don't use a liquid, they use gel. So a gel also can be an electrolyte. All right. Okay. Right. Note, if learners refer to movement of electrons, a mark is forfeited. All right. So please try to say conduct electrical current or conduct electricity, not just electrons. All right. So you lose a mark for this. Right, okay, next one. The next question says, for the investigation, write down the investigative question. Investigative question, right? What is an investigative question? It's a question where you're asking about the independent and your dependent variable. Clear? All right, you need to specify in your question which one is your independent, which one is your dependent. What is an independent variable? It is a variable that is being changed during an experiment. What is a dependent variable? Dependent variable is the variable that is being measured during an experiment. Then you've got your controlled variable. What is a controlled variable? It's a variable that remains constant in an experiment. Right. So let's look at what are we investigating here? Right. We've got different types of substances. All right. So let's check here. Learners investigate how the type of substance affects electrical conductivity. So what are we doing? We are changing the type of substance. And what are we measuring? We are checking whether these substances are going to conduct electricity. Are we together? So what is our independent variable? What are we changing? We are changing the type of substance. What are we measuring? We are measuring the electrical conductivity. So your question must relate to those two. Is that clear? Right, so your question, what are you going to say? You can say, yeah? Right, how does the type of substance affect electrical conductivity? All right, okay, let's check. How are you supposed to? What is the relationship between type of substance and its electrical conductivity? That's one way to say it, okay? Or how does the type of substance affect the electrical conductivity of a substance? The 2 marks. So your question must have independent and dependent variable, all right? Marking criteria, you've got your dependent and independent variables. So if your question is not going to be right, but you have stated your electrical conductivity and type of substance, you need to get 1 mark. Now that if you go on and ask a question about the relationship between the independent and the dependent variables, then you get the 2nd mark. So this is how your investigative question is marked. So what is the relationship between the type of substance and the electrical conductivity? Or you can say what happens to the electrical conductivity to change the type of substance. You can also state it like that. So that's your 2 marks for the investigative question. Right, we move on to the next one, dependent variable. Dependent variable. Already dependent variable, what did you say it is? It is the one that you measure. What are we measuring? We're measuring electrical conductivity. So your dependent variable becomes your electrical conductivity. And what is your independent variable? The type of substance. So those, so you've got conductivity, that's your dependent, and your independent becomes the type of substance. All right. Then the next one says, what is your controlled variable? What is a controlled variable? Other people, they normally define controlled variable as a substance that you control. That's wrong, because the one that I control is what I say I am changing. Are we together? What I'm controlling, it means what I decide I'm going to change. So like in this experiment, if you define it like that, then you're going to always be getting this mark incorrect. Controlled variable is a variable that remains constant. Are we together? Right. So what is remaining the same here? It's those that have got the same numbers throughout. So it's your mass of the substance remains the same. That's your control. You've got your temperature, always 25 degrees for all of them. So that's your 2 variables. And how many marks is here? It's 1 mark, right? So you only state 1. Clear? If it was 2 marks, you need to state 2. If it was 3, you state also 3. So in terms of controlled variables, there can be more than 1, right? There can be more than 1. In this case, there are 2 or even more. All right, so that's what we have for 2.2. We move on to the next one. It says for the investigation, predict with reasons the substance that will yield the following, the highest conductivity. Which one will yield the highest conductivity? All right, from the ones that are given, which one will have the highest conductivity? What do you say here? What's your answer?
Calcium chloride.
Yes, Zinedine?
I said calcium chloride, sir.
Calcium chloride, why?
Because out of the 3, it carries the most ions.
Right, so if you look at your calcium chloride, if you dissociate, let me just write it down. If your calcium chloride dissociates, it's going to form more, ions. Let's have a look. Let me just, right, so if you've got your calcium chloride, if it dissociates, you put it in water. This is a solid. Then you've got your calcium. Right, if it dissociates, you know calcium is in group 2. So that one is going to be a 2+. And your chloride is in group 17. That's going to be a minus. So if it dissociates, you're going to have your Ca2+ plus your chloride ions, Cl-. Right, this one becomes aqueous. And this one here becomes aqueous. And balancing this, when you balance, calcium is 1, calcium is 1. Chloride ions here, there are 2, so you put a 2 here. All right, if you check how many ions we have here, right, it's 1 here plus 2. So all in all, there are how many? 3 ions that we're going to create. All right, then we move on to the other one that was given. I think it was potassium chloride, am I right? KCl. Right, so you're going to have your KCl. If it dissociates, you put it in water. Right, you're going to have your K+. Potassium is in group 1, so it's a K+. Plus your chloride ions is going to be Cl-. So that's your aqueous. and that's your aqueous. If you check how many ions do we have here, we're going to have 2. So the more the ions, then the higher the conductivity. So your calcium chloride has got 3 ions, right? So it is more. But we still have sugar there that was given, right? Sugar, it's as we have seen, I think in the previous activity we saw sugar is C6H12, I think 12 or H22, something like that. C6H22 or 6, something like that, right? Your sugar, it is a molecular substance. When you take sugar, you dissolve it in water, it does not form ions. Why? Because it comes from a covalent bond. What is a covalent bond? It's a bond between non-metals. So there are no charges, no ions. So sugar won't do like what is happening here. So sugar is out, the sugar that was given there. So here you're going to have to check for the ionic compounds, which one is having more ions. So your calcium is with more ions, which is 3. Okay? All right, so let's have a look at the question again. Okay. So here, which one will have the highest conductivity? So the one that forms more ions on that equation, it's your calcium chloride. So yes, Zinedine, you are correct, because it forms more ions. So the answer is calcium chloride. Clear? Right, then 0 conductivity. It becomes your sugar. Why? Because sugar is a molecular compound. There's no ions. It does not form ions. So that's what we have. Right. So solution of calcium chloride, it is the strongest electrolyte. It is the highest concentration of chloride ions. Right. So you can state either one of those 2 reasons. Then the one that is not a conductor becomes your sugar because it contains no free ions. Clear? So this is how you should have answered question number 2. That's easy. Right, we move on to the next one. Question number 3. Let me just check how much time we have because I've got another lesson at 1:15. Okay, fine. So 2 test tubes A and B both contain sodium salt solution. After a small amount of barium chloride is added, the solution in both test tubes forms a white precipitate. Right? So both contain a sodium salt. All right? So there is sodium bonded to another anion. We're not sure which one it is. After a small amount of barium chloride is added, the solution in both test tubes forms a white precipitate. Is that clear? Right.
Yes.
Write down the type of reaction that takes place in the test tube. We have looked at how many types of reactions? We have looked at 4. What are they? Precipitation reaction. Am I right? We have looked at what else? Which other reaction did we look at? Yeah?
Gas forming reaction.
Gas forming reactions, isn't it? Right, that's number 2. The next one?
Acid base.
Acid base reaction, isn't it? Right?
Yes.
Next one?
Reduction oxidation.
Redox reaction or reduction and oxidation reaction. What is a precipitation reaction? It's a reaction that forms solid, right? One of the products becomes a solid, so we call it a precipitate. Then the one that forms a gas, it becomes gas forming. Acid base is the one where you react an acid and a base to form a salt and water. Then you've got redox reaction, is a reaction where electrons are transferred. So one loses electrons and the other one gains electrons. Those are the 4 types that we have looked at. So now, here we are told that a white precipitate forms. So what type of reaction is this one? It becomes the first one that we've spoken about, which is precipitation reaction. Clear? Right, we move on to the next one. A concentrated nitric acid solution is then added to each test tube to establish which one contains carbonate ions and which one contains sulfate ions. Bubbles are formed in test tube A. There's no reaction in test tube B. So test tube A forms bubbles, right? B, no reaction. Identify which ions, is it carbonate or sulfate, are present in test tube B. The one that is not reacting, what is it?
Sulfate.
It becomes sulfate, correct. Because carbonate produces carbon dioxide, isn't it? Right, so this is carbonate, the one that is forming bubbles. The one that is not reacting, that's your sulfate. So the answer there is sulfate for 1 mark. Right? Move on to the next one. Write down a balanced chemical equation that represents the reaction between nitric acid and the precipitate formed in test tube A. Right? So now we're going to have to write this one down. Right? Let me just quickly. You can write this nitric acid. Let me share this. Right. So in the other test tube, what we saw that there was the one that is forming a carbonate. We saw that it's a sodium salt, and we saw that it's a sodium carbonate. So from your crisscross, from first term, we learned if I've got sodium, it's a plus, and my carbonate, it's a CO3, 2 minus. And what is my ratio? My ratio there for the positive, it's 1:2. If I do crisscross here, carbonate is going to be 1, the sodium are going to be 2. So my formula is going to be Na2CO3. Right, so that's the formula for the carbonate. So I'm going to write Na2. So you need to start here because you need to have the correct formula. So it's Na2CO3. That's my sodium carbonate. It's going to react with nitric acid, which is HNO3. So you must know the formula for nitric acid, HNO3. Right? Then it's an ion exchange. So we're going to have an ion exchange. But before we do the ion exchange, we need to know the charges. Your sodium is plus, your carbonate is 2 minus, your hydrogen here is plus, your nitrate is minus. So you swap your ions, ion exchange. Your sodium is going to take your NO3, isn't it? So we're going to have our formula. It's going to be Na. You look at the ratio there, plus and minus. So ratio is 1:1. So your formula becomes NaNO3. Plus, you've got your carbonate ion that is remaining in the hydrogen. The carbonate must form a gas, so it's going to form CO2, carbon dioxide.
Plus H2.
Plus water, which is your H2O. So the bubbles that you see is because of carbon dioxide that is being formed. Right, then you put your, this is sodium carbonate, and you've got your NaO3, right? So you're going to write your state. This one becomes aqueous. You can add that. That's a gas. Right, and that's a liquid. That becomes a liquid. Right, this is aqueous.
So,
yes.
So can I ask a question, Mensa?
Yeah.
How do we know that how do we know that the one in the beaker A was sodium carbonate?
Oh, how do we know? We were told. Remember, on the initially on the question, we were told that it's a sodium salt. We're just told it's a sodium salt. But as you do your if you follow the question here, the ions that are present when you use barium chloride, for them to form a white precipitate, either it will be a carbonate or it will be a sulfate. So now we saw that in test tube A, it cannot be a sulfate. It's a carbonate that forms a gas. So what does that mean? It means the carbonate must be bonded to sodium. So this one must go to that one.
Yeah.
So that's why I started with this, because we're told we started with the sodium salt. I think if you check on the question here, there's a part that is saying that, which says 2 test tubes, A and B, both contain a sodium salt solution. Which salt? That's what we don't know. That's what we get from this part here, which says carbonate or sulfate. So if A will have maybe sodium carbonate or sodium sulfate, depending which one is the correct one. Are you answered?
Yeah, I think so.
Okay, so I'm getting it from the first part of this question. Yeah. All right, so that's what you get. So it's 3 marks. So your 3 marks is going to be writing the correct formula for your reactants, correct formula for your product, and balancing of that particular equation. Right, then just the balancing, I think I'll stop with this question here because my time is up. Right, let's check if it's balanced. Sodium here, I've got 2. All right, sodium, I've got 2. Let me use blue. Okay. Sodium is 2. Sodium is 1, so I put a 2 here. All right, so sodium is balanced. All right, carbon is 1. Carbon is 1. Oxygen here, I've got 3 plus 3, which is 6. This side, I've got oxygen is 3 plus 2 plus 1, which is also 6. Then hydrogen, I've got 1. But this side here, I've got 2. So I need to put a 2 here. So my hydrogen are balanced, as well as the nitrates, NO3s, they are now balanced. So my equation is now balanced. Right, I'll stop here. My time is up. The next lesson must continue, which should be mathematics. So are there any questions? Tomorrow we'll continue with this. Please, if you are behind, make sure you catch up. We need to continue with term 3's work because some of the term 2's work has been removed or it has been trimmed because of time limits. So your final exam might not contain some of those topics, but I will clarify everything as we go along. Clear? Right. So please, we start with term 3 continuing so that we are able to prepare for the tasks and the tests that should be written for term 3. Any questions? Please, I will send, those who are at home, I will send you the time schedule for the tomorrow's lesson. Then you guys will need to join accordingly. Yes.
So shouldn't you have first made the reaction with barium chloride?
Should we have what?
Shouldn't you have done the reaction with barium chloride first?
I can't hear. What are you saying?
Shouldn't you have done
barium chloride?
Yes.
Or the first reaction? Okay,
Yeah.
wait, I'll clarify that in our next lesson. I see what you're talking about. Let's start with that in our next lesson tomorrow.
Mr. Mbela, sir?
Yes.
Before you leave the lesson, can I just ask Mr. Masugume if he can hear me to send me the link for the maths Zoom?
Okay, who, Mr. Masugume?
Yes, I think he's on the live now, or he's in that class, the other
Okay,
class.
he wants to come through. I'm not sure he's going to join from his other class. I'm not sure. Okay, so what must I do? I must check if you can hear Mr. Masugume, or what must I do?
Hello.
Yeah.
Hi, sir. Can I just want the link, please? The link to the maths lesson.
You need.
I posted.
Don't you have maths with grade 10s now, sir?
Yeah, it's now.
Yes, I do. I'm worried. I have grade 10s. I posted it on the group.
Okay, so please send it to me. Or post it on HP Educators or Zoom HP links.
Okay. You don't have grade 10 HP?
No.